Hello, today's video is going to be on trapezoids, another quadrilateral. Now, trapezoids are a little bit different than all the other quadrilaterals we've talked about because the trapezoid is not a parallelogram. So far, parallelograms, rectangles, squares, and rhombi, those are all part of the parallelogram family. Trapezoids are not. And if it's not a parallelogram, that means opposite sides are not going to be parallel and none of those properties are going to apply. In a trapezoid, it is a quadrilateral with exactly one pair of parallel sides. So when I look at the trapezoid we have here, we have that the top is parallel to the bottom. So although we don't have two sets of parallel lines, we still have one, so we can still apply the parallel line properties to that. So if the top is parallel to the bottom, I can choose the transversal on the left, or I can choose the transversal on the right. In this case, I'm going to choose the transversal on the left, and if you remember from our parallel lines, from our parallelograms, we have same side interior angles here, and if they are same side interior angles, that means they're going to be supplementary. So being supplementary, that means they're going to add up to 180. So we've got 4x plus 12 plus 2x minus 6 is equal to 180. We combine our like terms, 4x and 2x is going to be 6x, 12 minus 6 is 6. We move the 6 over, giving us 6x is equal to 174, divide by 6, and x is equal to 29. So again, even though we don't have two sets of parallel lines, one's good enough to use that transversal to get those same side interior angles. In a trapezoid, we have a median, and we've talked about medians in triangles, and those were called midsegments. And if you remember, a midsegment is formed by connecting the two midpoints together. So because FC is going to be a median, that means that F is a midpoint, and that means that C is going to be a midpoint. In order to be a median, or midsegment, it has to connect the two midpoints together, and midpoint is going to be halfway along those sides. The formula to find the median of a triangle or trapezoid is half of base 1 and base 2. So the bases are the two sides that are parallel to each other. So we've got, in this case, the top being parallel to the bottom, which means that this is a base and this is a base. The two sides that are not bases are going to be the legs of our trapezoid. So the median formula is equal to 1/2 the bases. So in this case, the median is 2x minus 6, and that's equal to the two bases added up. So one base is 26 and one base is 14. It doesn't matter which one you make base 1 and which one you make base 2. Go ahead and simplify the right-hand side. 26 and 14, that's going to give me 40. Half of 40 is 20, and now I can just solve for x. We move the 6 over. 2x is equal to 26. We divide by 2, and we find that x is going to be equal to 13. But we're not done yet. We also wanted to solve for y. Now, because C is the midpoint, that means that these two segments are going to be congruent, so to solve for y, we do 4y equals 20. We've got two congruent segments. Remember, if we set something equal, that means they have the same length, which is going to leave us with y being equal to 5. All right, our last idea for today's video is the isosceles trapezoid. We talked about isosceles triangles, and an isosceles trapezoid, just like the triangle, that means that we have two legs that are going to be congruent. In a trapezoid, we have two lines that are parallel. We don't have three parallel lines. So the two sides that are parallel, if you remember from the last problem, those are going to be our bases. In an isosceles trapezoid, the base angles are going to be congruent. Now, if this is the base and this is the base, that means that this is a base angle and this is a base angle. These two base angles are congruent to each other. This is a base angle and this is a base angle. Those two angles are going to be congruent to each other. The legs are going to be congruent. So MH is a leg, AT is a leg. Those two pieces are congruent to each other. And the diagonals are congruent, which means that MT has the same length as AH. So we're going to make sure that we apply all that information. So given that it's an isosceles trapezoid, we are given that MT is 6x minus 20, MA is 7x plus 4, HA, and HT. So we were given MA, which is the top, and HT, which is the bottom. We don't know anything about the relationship between the top and the bottom. We know about the median, but we don't have a median here, which means this information is completely useless to us right now. What I do know is that my diagonals are congruent. MT is a diagonal and HA is a diagonal. And because it's an isosceles trapezoid, the diagonals are congruent. If it's not isosceles, then the diagonals are not congruent. Since they are congruent, we can set them equal to each other. Remember, we move the smaller x first to keep our x positive. Then we add our 20 over. Negative 10 and 20 gives us 2x is equal to 10. We divide by 2, and we find that x is going to be equal to 5. Now we still need to solve for y. We are given MHT, so MHT, talking about this big angle right here, and ATH, this big angle right there is y plus 12. We know that those two base angles are congruent, so we can set 5y minus 28 equal to y plus 12. We move the smaller y over, giving us 4y minus 28 is equal to 12. Add our 28 over. 4y is equal to 40. We divide by 4, and we find that y is going to be equal to 10. All right, so for the trapezoids, you want to make sure that you look closely. Trapezoids really only have the top and bottom, the bases parallel to each other, which means you can use same side interior angles. That's it. Unless you have an isosceles trapezoid. Only when it's isosceles can you apply all of these properties of congruent diagonals and congruent base angles and congruent legs. So make sure that you read the directions carefully to see which kind of trapezoid you have. And that's it.